All right, and welcome to the lesson 3.2 notes. We'll be talking parallel lines and transversals today. Uh, Definitely connected to lesson 3.1. So if you haven't watched or taken those notes, we got to go back and get some of those concepts written down. So I guess we will take a second here to kind of review that stuff to start. So let's jump in. Let's do it. So going back basically to the previous lesson, we're talking this new concept of just what the heck is a transversal. Basically, what that means is um, let's maybe draw it, just situate it differently. All right, I've got some random lines here, line here, again, just another random line segments, or let's put arrows on them, call them lines. So I got lines here and here, whatever. Those would intersect somewhere off the page there. Not a transversal. Here's however it intersects it, but this pink line, and that's all we need to call it for right now, is what we would call a transversal. And basically, what it is, it's a line that intersects any two or more other lines in two spots. Okay, so clearly we've got an intersection right here. Maybe switch it over, and we've got an intersection right here. Okay, so that's what a transversal is. And when we get that situation going on with two lines, right? Like we're seeing here, the black line and the black line. When I get that intersection taking place, we end up creating these 1, 2, 3, 4, and then 5, 6, 7, 8 angles. And so we said the big takeaway from the first lesson from 3.1 was that, in addition to our vertical angles from previous lessons, like so 1 and 3 would be a pair of vertical angles, just for example. 2 and 4, 5 and 8, 6 and 7, those would all be vertical angles. We know stuff about them. And in addition as well to our linear pairs, right? 1 and 4 would be a linear pair. 1 and 2 would be a linear pair. 2 and 3, there's a bunch of them up there. All right, basically side by side, making a straight line. So yeah, a whole bunch of linear pairs. In addition to those two, we came up with, I'm trying to think off the top of my head, I think 4 different, 1, 2, 3, 4. Well, let's list them here. What are they? The corresponding angles. Corresponding angles. So just as a review here, corresponding angles, we need to be able to recognize this at this point from based on the previous lesson. Angles that are in the same position in relationship to their line. So let's just go ahead and call this line 1, just for the sake of reference, and call this one line 2. And the transversal. All right, so in line 1, I've got this angle 1 kind of in the upper left. It's above the transversal. Right, so if I'm talking kind of like it's above this pink line and to the left of the black line, so if I come down here and look, hey, above the pink line, but to the left of the black line, 1 and 5. Okay, so we've got 4 different sets of corresponding angles. Angle 1 and 5. All right, and you're like, well, we did this already. What the heck's going on? But it's important that we recognize the names. Like, hey, those are corresponding angles. 4 and 6. Maybe we don't have to list them all, but or we could. So angles 2 and 7, and then angles 3 and 8. Okay, so those are what we call new vocab for us, corresponding angles, same position. The other, well, let's run through them. What's the next one we talked about? We talked about, I think it was alternate interior angles. Let's use the abbreviations, right? This isn't new for us. Alternate interior angles, alternate interior angles. So again, my picture's kind of rotated differently than we saw in the previous lesson, the example we did. So interior would be in between the two lines, in between lines 1 and 2. So 3, 4, 5, and 7 would be my interior angles. And then alternate interiors are on different sides of the transversal. So we're talking like angles 3 and 5, and then 4 and 7. Why not 3 and 4? Those are alternate sides. Those are already called a linear pair. So we said, well, we're not going to rename it. So 3 and 5, angle 3 and angle 5 and angle 4 and 7. All right, so we're doing a quick review here. Hopefully quick. Let's do alternate exterior angles. Alternate exterior angles, that's what that stands for. Go back, watch the previous lesson if that doesn't mean anything to you. Alternate exterior would be angles, exterior angles would be 1, 2, 6, and 8. If these 4 are interior, then 1, 2, 6, and 8 are exterior. So 1 and 8, angle 1 and angle 8, and angle 2 and angle 6. We did consecutive interior angles. So now we're back to interior, but this time we're talking consecutive in a row, right? I've won 2 consecutive world championships or whatever in a row, right? So in a row would be like 3 and 7. They're right next to each other again, not 3 and 4. Those are alternate. Those are linear pair, actually. They're on different sides of the transversal. But 3 and 7 are consecutive. So angles 3 and 7, and then 4 and 5. The one that we didn't like add, and you should have, I kind of ran out of space, to be honest. We're same side exterior angles. So it's kind of the longer one, a little bit weirder looking, SSEA, same side exterior. And I think that one almost spells it out exactly what we're looking for. Where if as long as we recognize, hey, 1, 2, 6, and 8 are exterior, we want the ones that are on the same side of the transversal. So in our example, we'd say angle 2 and angle 8, and angle 1 and angle 6. I can't stress enough like how big of a deal it is that we can recognize. If I say, hey, come up here, and I need you to identify a pair of corresponding angles, like we need to be able to look at a figure and do that. Okay, not only for the previous lesson, but for this lesson and the next one, 3.3. Okay, so that's why it took a little bit longer there to review those. I know it went quick, so you got to go back and watch the previous lesson if that was like what. Okay, so where do we get to new stuff today? What are we talking about? We said really the only thing that's changing today is these 2, in our case, the black lines 1 and 2. Instead of them being just kind of random lines, let's make those parallel, because then we start to see different relationships showing up. Okay, so here's the deal. This is new. Let's add this to our notes. We'll kind of make it, I think we can make it a little bit smaller than I did on the previous lesson. So now our new lines. All right, I'm kind of just drawing random lines. Let's call it line L. And it doesn't matter how far apart they are. I'll try to keep them close here. So we're, again, I got to be a little bit better with my space. So we're indicating, or I tried to make those parallel. We talked in the previous lesson as well as how do I guarantee to a reader that these are parallel? There we go. We put the little arrows on them to say, yep, we for sure know that line L. So I could say this right now, line L is parallel to line M. And again, we're also reviewing, that's a concept from yesterday, using this. It looks like an 11 the way I wrote it, but those are little parallel lines. Line L is parallel to line M. Okay, so they're parallel. And it doesn't matter how I draw my transversal. Should it look like this? Or should it look like this? Should it look like this? To be honest, it doesn't matter. I would caution maybe against doing this one, because now all of a sudden I make everything look like a right angle, which that's a very specific kind of case there. I don't think I want to do that. So let's let's put it on a little bit of a quote unquote slant here. Just call this line N. Okay, so I've got my transversal. The only difference now is that we've kind of forced lines L and M to be parallel. All right, so here we go. We've still created those same. Let's randomize the numbers here a little bit. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, whatever. I just feel like mixing it up just so we don't. Sometimes people fall into this like, oh, it's always 1 and 8. It's always 2 and 3. Those are always my alternate interior. I'm just trying to help us out without making it too crazy. All right. So we've got all these different angle pairs again. They're still there, right? Like angles 3 and 5 are always going to be called a linear pair. Angles 2 and 3 are always going to be called vertical. Our new ones, 8 and 7, are always now going forward alternate interior angles. 6 and 3 are same side exterior. 5 and 7 are always called corresponding angles. That still carries over. The new part today, here it is, the big reveal. There's relationships here that I know, as far as I know certain angles have to be the same, have to be congruent, and I know certain angles have to be supplementary. Okay, so let's go back. Let's add the two previous things that we know. What do we know? We know the linear pair postulate from a previous chapter. Actually, the linear pair postulate says all linear pairs are supplementary. So for our sake, and we're not going to list them all, but maybe we can just say that linear pairs are supplementary. That's not new. All right, still add it though. It goes right with this section. Linear pairs are supplementary. The example, and there's just too many to name there, but the example could be the measure of angle 3 plus the measure of angle 5 equals 180. How did you know that? How did that have to be true? Because the linear pair postulate says so. It says that linear pairs are supplementary, and I think we know that. So again, I could do this with 3 and 8, 2 and 5, 1 and 7, whatever. Another property that came up in the previous chapter was the vertical angle theorem. I can't remember. It wasn't the first theorem that we did. I think we did the right angle theorem, but it was short and sweet. Basically, it said that it was one of our first theorems that vertical angles are congruent. Vertical angles are congruent, right? That's something that we should hopefully recognize here. So beyond just identifying, oh, hey, 3 and 2, yeah, those are vertical angles, right? By definition, that's what they are. But a property of vertical angles is that they're congruent. So again, without listing them all, we could pick, let's do a different pair. Let's go down here. Angle 6 and angle 7, those are vertical angles. So we could say angle 6 is congruent to angle 7. How did you know that? What was your reason? Why would you say that? So you can kind of see where I'm going here. I'm kind of being, whoops, didn't mean to do that. I'm kind of being a little bit silly, but you can kind of see like we're getting a little bit proofy the way I'm talking about it. How did you know that 6 was congruent to 7? What would be a reason in a 2-column proof? Oh, because the vertical angle theorem says that those have to be congruent. All right, so that's a review. That's nothing new from today. Here's the new ones. Those same angle pairs that we just came up with, they all have relationships there. Okay, and you can kind of see, here's the first one, the corresponding angle postulate. All right, linear pair postulate, vertical angle theorem. So we're basically going to add however many names we came up with there. What did we have? 1, 2, 3, 4, 5. We'll come up with 5 new theorems and postulates. But here's the beauty of it. As long as you know the names of the pairs, you basically know the names of the theorems and postulate. It's not like we're coming up with a weird name. It's called the corresponding angle postulate. What do you think this one's going to be? The alternate interior angle theorem. Alternate exterior angle theorem. Consecutive interior angle theorem. Same side exterior angle theorem. So why is this one a postulate? We basically, long story short, we have to keep one a postulate and use that to help us prove the other ones completely true. So that's why the other ones can be theorems. We basically decided, hey, you know what? Let's keep the corresponding angle in a postulate, and then we can use that to help prove the other ones. All right. Hopefully we can squeeze this in. I'm going to change colors here. You should be adding this to your notes. I'll scroll through the other ones, so if you miss it, you can kind of pause on it and add those. But for the let's just here we go. The CA postulate. What does it say? Well, before I just say here's what it is. What is it? So let's look. Angle 3 and angle 1, those are corresponding angles. If you had to guess, angle 1 and angle 3, are those angles supplementary? Are they congruent? Are they the same? And I think you can be strategic, and if we make our picture decent here, I look and say, you know what, that looks like 3 looks like an acute angle. It just does. It looks small, less than 90. This angle 1 right here, yeah, that looks about the same, right? And I don't have to be perfect as long as my lines were close to being parallel looking and I drew my transversal strategically. Yeah, that's what the CA postulate says. The corresponding angles postulate says all 4 of those angle pairs have to be congruent. Okay, 3 is congruent to 1, 5 is congruent to 7, 2 is congruent to 4, 8 is congruent to 6 because of the CA postulate. So we'll do kind of what we did over here on the right and just say corresponding angles are congruent. Now, before I get too far ahead of myself, this is only true. Well, everything we're writing right now and that I'm going to write in red and hopefully you're going to add to your notes, this is only true when we're working with parallel lines. Like that's a must have. I need to know that the lines are parallel if we're going to say any of the stuff that we're saying from here on out. Okay? Go back and look at our last example. This wasn't true. The vertical angles were still congruent, right? 6 was congruent to 7, 5 was congruent to 8. But if you looked at like angle 2, let's just highlight them here for a second. Like if I look at angle 2 and angle 7, right? Those are right there. That's in our corresponding angle notes that hey, those are corresponding angles. Those don't look the same, right? And I know it's hard. Well, you can't really trust our eyes, but those just aren't. Those are not. They're not going to have the same measure. Well, why not? You just told me, Mr. Kroll, that parallel lines, or when I'm sorry, I kind of gave it away. That corresponding angles are congruent. That's only true when the lines are parallel. Okay, that's the difference between the previous lesson and this one. We force these lines to be parallel. Okay. Oh, I feel like I beat it to death, but it's a big concept. Okay. All right. So corresponding angles are congruent. Example, can we do it right here? Example, we won't list all 4 of them, but angle 3 is congruent to angle 1. Okay. Proof-wise, and I know I'm kind of getting ahead of myself here a little bit, but I said, hey, how do you know? How do you know angle 3 is congruent to angle 1? All right, you just made this bold statement. 3 and 1 are congruent. What? I would have to say, well, I knew the lines were parallel. You know, that was given to us. And then because of the CA postulate, oh, yeah, sure. 1 and 3 have to be congruent. All right, let's roll with it here. All right, next one up. I'm going to try to stay. Maybe I should change colors here just because I know it's going to get tight again. Okay, CA postulate done. Next one, the alternate interior angle theorem. So we'll just go in the same order that we learned them in the previous lesson in 3.1. So the alternate interior angle theorem says what? Let's take a look. That's right. 8 and 7 are examples of alternate interior angles. So this one looks like a big old obtuse angle right here. What about 7? It looks like a big old obtuse angle as well. So if I had to guess, I think I could make an educated guess here and say that alternate interior angles are congruent, again, when the lines are parallel. So we could definitely say that angle 8 is congruent to angle 7. All right. Yep, absolutely. When the lines are parallel, that has to be true. That's my reasoning. Why? Lines were parallel. Alternate interior angle theorem says that when lines are parallel, got to be congruent. Sweet. All right, maybe I can squeeze one more in the bottom here. I might have to erase and add some new ones. But where did we go after that? I think we did alternate exterior angles. So you better believe, let's see, that we have an alternate exterior angle theorem, which says that alternate exterior angles are dun 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 what? I don't know. 5 and 6. Let's see. 5's alternate exterior with 6. Those look big old obtuse, big old obtuse. Okay, I believe that. I think alternate exterior angles are congruent. And we would be correct. That's exactly what they are. So example-wise, we could say angle 5 is congruent to angle 6. All right. All right. Well, so here's what I'm going to do. Instead of just kind of skipping them, I'm going to clear this. Hopefully, up to this point, you've you've added this portion of, if you're like, oh my gosh, he's erasing it, what do you got to do? Go back, just rewind it and add that part. That's review. This way we can finish with everything being kind of nice and just the new stuff, I guess, on the page. What haven't we talked about yet? Let's go back to our list. We learned them in this order. Corresponding, alternate interior, alternate exterior. Next one up is consecutive interior. Okay, cool. We can do that. Let's talk about the consecutive interior angle theorem, which says consecutive interior angles are what? Let's look. So consecutive, this is where it's so big of a deal that I got to be able to recognize this. 2 and 7 would be an example of consecutive interior. 8 and 1, consecutive interior. Awesome. Well, here, as I'm looking at it now, if my picture is decent, 2 looks acute, 7 looks obtuse, right? We said that earlier with some of these other ones. So absolutely, these are not congruent. We said what's really kind of the only other option here? They would be supplementary. Oh, okay, so changing it up a little bit on us. Let's just abbreviate. I'm going to run out of space. Supplementary. So it's kind of like that linear pair postulate where we would say the measure of angle 2 plus the measure of angle 7 equals 180 degrees. All right. So that's our first kind of different one. So far, CA postulate, AIA theorem, alternate exterior angle theorem, all said things were congruent, but we got to be careful. They don't all work that way. Not everything's congruent on this picture. There's supplementary angles as well. So consecutive, that's our first one, new one that we're looking at here today, like the linear pair postulate that says 2 angles add up, their measures add up to 180. What are we thinking on this last one? Where are we going with this? Last one, our same side exterior angle theorem says what? That same side exterior angles are supplementary. It's that same deal. Look at angle 3 and angle 6. Those are definitely, they fit our definition of same side exterior. All right, 3 and 6. Okay, yep. But they don't even look close, right? This one looks acute, that one looks obtuse. And again, I'm not trying to say like, hey, always just trust your eyes or whatever. I mean, maybe it was just a hand-drawn picture, but if I'm making an educated guess, I wouldn't guess congruent there. I would have to go supplementary, and that'd be correct, actually. So example-wise, we'd say something similar like the measure of angle, let's go on the other side. The measure of angle 5, I have no clue what it is, the measure of angle 5, but when I add that to the measure of angle 4, because those are same side exterior, I know for a fact that those have to add up to 180 degrees. Little cluttered, a little tight. Hopefully you got some space in your notebook where you're spreading them out a little bit. You could list all of them if you wanted to as far as the other. I could say for this one, if I want to say measure of angle 3 plus the measure of angle 6 equals 180. But that's it. Like, that's the big deal. Like, that's the new thing now. Parallel lines. Okay. These new relationships are there. All right. So what does the homework look like? What am I going to ask you to do? What do we got to do with this stuff? I was kind of hinting at some proofy type of things, and we're going to kind of do it here. I know it's a little bit more algebraic or numbers, which we kind of like, I think. But I am going to ask you to, like, which theorem or postulate did you use? So let's go through a couple examples. You can see I don't have a million of them. There's 1, 2, 3, 4. The rest is just examples now. But follow with. Make sure you're doing the same thing. Add these to your notebook. I'm actually going to shrink this. This is too big. You guys can see fine. Look at that. All right, give me a little more room to work. So here we go. It says the measure of 3 of the numbered angles is 125. So I've got 1, 2, 4, 6, 7, 8. So it's kind of using the same picture. So I'm looking here. There's big things going on. Parallel. Make sure we see that. Like, that's a big piece for us. Hey, parallel. Okay, that's huge. So all those relationships that we just talked about are true. Identify the angles. Which ones have to be 125? So I'm thinking, all right, let's see here. I'm going to go the first one that jumps out as me is this number 1 over here. The measure of angle 1 equals 125 degrees. Wait a minute, hold on. How did you know that? Here's now the second part. Which postulate or theorem did I use? It actually wasn't a new one. I said, hey, I know what a vertical angle is. These two are vertical angles. The vertical angle theorem says that has to be 120. Or I'm sorry, 125. So I don't think it hurts to put that in there. All right, sweet. Yeah, it's got to be 125. There's two other ones? Wait, what's going on? So now I think I'm definitely going to have to, we got to get down here to some of these. So here's where it starts to get a little bit open-ended, okay? And I'm not saying that the way I'm going to do it right now is the only way to do this, because by using this information that I just added right now, I think I could figure out some of these other ones. Okay, so I'm going to do number 5, like angle 5 next. I think I'm pretty confident that the measure of angle 5 also has to be 125. Wait a minute, how do you know that? How does that have to be, like, why does that have to be true? So there's two things I could say right now. I could say this angle right here and this angle right here. When I put those together, what name do I have for that pair? Take a second. Oh, that's right. Those are called alternate interior angles. And when the lines are parallel, alternate interior angles have to be congruent. So I would say that. I'd say the AIA theorem, the alternate interior angle theorem. Are you starting to see why it's so important to be able to recognize those names? Now you might say, well, that's not the way I did it, and so I'm not going to do this for every single one, but I just want you to see that, like, it's okay. Like, what if I did this? What if I said this angle right here and this angle right here? Do I have a name for that pair? Let's see. It's kind of like below the transversal to the left of this line, below the transversal to the left of this line. Those are what we call corresponding angles. I'm kind of using a previous number that I came up with, but I can for sure say that I wouldn't change the measure of 5 is still 125, but I might have as like a second, like not a second, but a different way of justifying this because of the CA postulate. Okay, so I'm definitely not saying to write both of these. There's actually probably more that we could do. Postulator, that's weird. But I just kind of want you to at least see for the first one here, like there's different ways we could do these. All right. We'll clear that one. I'll put a 125 in there. And then I need one more angle up here. I think I'm going to go with angle 7 because that's correct. That's 125. But how did I get there? And again, it's for the same reason. Maybe I looked at this one right here and this one right here and said, hey, I got a name for those ones. Those are alternate exterior angles. Maybe you looked at this 125 and this unknown and said, hey, you know what? These are corresponding angles. The CA postulate says. Maybe you just went off this one right here. Do I got another color? This one right here and this one right here are vertical angles. I use the vertical angle theorem. Hopefully that point's getting across there, that there's flexibility here as far as how and obviously the more information you put on the page, I wasn't able to do this right off the bat until I added these other numbers. But let's say like right here, given what I have on the paper right now, if I wanted to say the measure of angle 7 equals 125, which it is, as of right now, the only way I could justify it would be to use the corresponding angle postulate, because I haven't indicated this or this yet. Okay, so that's kind of how that works. You know what? I'll do the CA postulate here for this one. But hopefully, you saw that, hey, there was different ways I could have got there using previous information. Okay. All right. So that's a lot of what I'm going to ask you to do with a section like this is find some of the missings. And the next one we'll look at is find an X, find a Y, still justify it, explain how you're getting it. So let's jump to the next one. That one almost looks too small, but I think we'll be all right. Find the value of X and Y. So this one's a little bit more. There's an algebraic setup that's going to go with these ones. And it kind of depends. Sometimes I might have to find one to find another. I might use the X to find the Y. I might use whatever. So I might find Y first. I might find X second. I guess that's the same thing. I find y first, find x first. Let's see what I got here. I think I could find these both independently based on this information. So again, it's important to recognize, all right, I've got some parallel lines here. That's kind of a big deal for us. Let's start with x. Why not? Really, can we start with x? Is there enough information there? Say, yep, because this angle right here, this 113, and this angle right here, I have a name for. That's kind of what it boils down to. Do I have a name for that angle pair? Sure. Yeah. 113 and 3x minus 4, whatever that angle we would want to call it. Those are alternate exterior angles. Those have to be congruent. So as I go to like set up, like what does congruent mean? They have to have equal measures. Oh, sure. 170. I'd add a 4 to both sides. 117 equals 3x. Luckily, I got my calculator sitting here because I don't know that one off the top of my head. 117. Whoops. Maybe not. 117 divided by 3. 39. X equals 39. I circle it. And really, like, where am I putting my justification? I'd be putting it right here. Like, this is the spot. Like, how were you able to set up that equation? Because the alternate exterior angle theorem said that those have to be equal, essentially, that those had to be congruent. Therefore, their measures had to be equal. All right, so you're still justifying it. Let's do y. What's the relationship? And again, I have some options here. I look at this and see, and I kind of wrote over the top, but this angle right here, that's 113, and this angle right here, those are not congruent. So don't go falling in love with equals, 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 equals. I can't set everything equals together or all the time. I see those too, and this is actually going back to the previous chapter, chapter 2. These are what we would call a linear pair. So the linear pair postulate says those aren't equal, they're supplementary. So my algebraic setup is 113 plus 3y plus 2 has to equal 180 degrees. If I want to just justify it right away, that is because of the linear pair postulate. All right, so there's my justification. Now I got to solve it. I'll get my y. Just before we get there, are there other ways I could have gotten this? Sure. Right? I could take this 39 and actually plug it in. Actually, I don't have to because I know exactly what's going to happen. I could say this is 113. I could do different things. And you know what? I want to move this 113 over here and say, hey, that's got to be 113. What would be your reason for that? The vertical angle theorem. I could do the linear pair postulate here and figure out what this measure has to be. Right? So there's different things I could do. It's kind of how you're seeing it. All right. I usually try to find the shortest way. I saw these two side by side. That's a linear pair. Linear pair postulate says they got to be supplementary. All right. Let's solve this. We can put these together. 115. So I'm just kind of combining those right there. Plus 3y equals 180. We'll subtract it. Again, I'll use my calculator. I know you can't see me. 180 minus 115 equals 65. Let's divide that by 3. Oh, not a nice number. What happened? Oh, whatever. Did I screw something up? 113 plus 3y plus 2. No, I think we're okay. It always just makes me leer, and I know you guys kind of do the same thing, that when something doesn't work out that way, you're like, something screwed up. No, I think it's okay. I mean, it's not a beautiful number. It's 20. My calculator says 21.666667, which is 21. We can just say 21.67 if we want to round it, or 21 and 2/3. I'm not going to be super picky with something like that. It's more, hey, do we see the setup? Can I justify it? All right, so I think we're okay there. Y equals 21 and 2/3. Whatever, it is what it is. Let's do one more like that. Okay, and again, I'm not trying to just bury us with examples here, but I think we're seeing something here in this one that we haven't seen yet. Okay, so it's just find x, find the value of x. There's a couple different expressions, and that's all we get though. So hopefully, you're thinking like, well, there's probably one of two setups. Parallel, just important to note, are these equal? Are they supplementary, right? That's pretty much my options. All right, we're not doing anything with 90 right now or complementary or anything. So it's are they supplementary? This one's going to require two steps. So because right now I don't have a name for this angle, I'm just kind of highlighting. We're talking about this angle right here and this angle right here. I don't have a name for that. They're not corresponding. They're not consecutive interior. They're not a linear pair. They're not vertical, right? It's none of the above, basically. So here's how I see this. I would do this. I see this angle right here, this unmarked one, and I'm using the same color for a reason because those are vertical angles. This 3x minus 7, whatever that is representing, is also applied right here. Okay, so I would start this off with like a step of, well, I did something, right? I moved an expression. How did I do that? I used the vertical angle theorem to move that expression. Okay, that seems kind of weird, but why did I do that? Because now I do have a name for this angle right here, what was originally blue, which for some reason I'm coloring green, and the red one. I have a name for this angle, and this one, this pair. That's called a consecutive interior. Those are called consecutive interior angles. So, okay, I can use the consecutive interior angle theorem, which says that if you have parallel lines and you have consecutive interior angles, they must be supplementary. Oh, okay, sweet. So that's my setup, that 3x minus 7 plus x plus 5 have to add up to 180. So again, be careful. I've seen it so many times where people just start grabbing, oh, this has to equal this. This has to equal this. And they're not. They're supplementary. All right, I don't remember. This one work out a little bit nicer. So I did the justification first. I'm not saying you have to do it that way. A lot of people are probably gonna, oh, you know what? These aren't the same. That's obtuse. That's acute. They got to be supplementary. Sure, fine. But this one would like require a two-step like justification minimum, just to say like, hey, yeah, that's how I move stuff around. Are there other ways? Just like before, absolutely. Could I have jumped this x plus 5 up here? Sure. Corresponding angle postulate says that, yes, this one also has to be x plus 5. I would finish it with the linear pair postulate then, if that was the way I originally saw it. Whatever, let's solve this here. I don't want to confuse you too much by doing like 20 different ways to solve the same problem. So I'm combining some like terms here, negative 7 and 5. Okay, we'll add a 2 to both sides to get 182. And then we'll divide by 4, which one last time is 182 divided by 4, 45 and a half. Still, I don't remember getting all these decimals when I did it before, so I'm just doing a quick check, to be honest with you. Oh, okay. Yeah, I guess it worked out. I was just doing a quick check to make sure that they worked out. And yeah, x equals 40. I mean, not that that's a terrible number, right? It's 45 and a half. But I just didn't remember getting those before. So, yep, 50 plus. All I did was I just very quickly, I know you couldn't see me, I plugged this in right there. I plugged this in right there. I'm not saying you had to do that. It didn't say find the angle measures or anything. But I wanted a quick confirmation. All right, this has all been building. All right, and everybody's going to freak out here, but we've already done this one. Oh no, it's a proof, an actual 2-column proof. I can't do it. Skip it. No, don't do that. Okay, it looks scary, I know, but let's take a look at what's going on here, okay? So it's totally blank. Oh no, we can do it. Okay, it's everything we just did. If you feel good about those last couple examples, you're like, that was so easy. Like they're either congruent, they're supplementary. So I look here and I say, all right, N, right? Line N and line P are parallel. So we said that was a huge deal. And a lot of times that's going to be our given. So let's mark it. We got to still, just like before, say this. Okay. And then let's, in the same, while we're doing it, line L. Where's line L? Right here. I'll just mark it on this one. This might be the first time we're seeing this. I'm going to use I'm going to use 2 arrows on those ones just to indicate that not all 4 lines are parallel. Not that we would think that, but that's how you do that. You would say, you use a different set of markings. Okay, so that's given to us. We were given that those lines were parallel. What are we trying to prove here? We're trying to prove that 1 is congruent to 4, right? Just like before, this is our guiding statement. 1 is congruent to 4. I don't know that's true right now. Like, it's not just saying, oh, hey, 1 is congruent to 4. That's what we're trying to show. So kind of taking a step back, I need to work my way from 1 to 4. These are not alternate exterior angles. Some people want to do that. They're not vertical angles, right? I don't have a name for this pair from jumping from 1 all the way down here to 4. So I think I'm going to have to work my way over there. Just like everything else we said, there's options here. Is 1 congruent to 2? Yeah, because of the vertical angle theorem. Is 1 congruent to 3? Yeah, those are corresponding angles, so the corresponding angle says those are congruent. Is 3 congruent to 4? Yeah, I have a name for that. Those are alternate exterior angles, so they have to be congruent. What I'm kind of verbally doing, that's exactly what the proof is going to be. You're kind of asking yourself, do I have a name for this pair? Okay, so the long way would be to do 1 is congruent to 2, vertical angle theorem. 2 is congruent to 3, alternate interior angle theorem. 3 is congruent to 4, alternate exterior angle theorem. Because those are just the names of them. If I want to shorten it up a little bit, which I know most of us probably want to do that, I can cut out that 2. I don't have to work with the 2. So I could right off the bat just say, hey, you know what? I'm going to introduce this. 1's coming into the proof right now. 1 and 3 are 100% congruent. I know for a fact that those are congruent. Why? What name do I have for those? They are corresponding angles. So the corresponding angle postulate says that those have to be congruent when the lines are parallel, which we knew they were. Awesome. I also know, well, that actually would be those 2 angles when those lines are parallel. All right. What about 4? We got to introduce 4. So I can't, there's nothing else. I got to introduce 4 before I say we're done. So for angle 4, what do I know about angle 4? Let's see. Angles 3 and angle 4, those are the ones that I have a name for. I have a name for 3, and when I put 3 and 4 together, I have a name for that pair. Those are called alternate exterior angles. So the alternate exterior angle theorem is what says those have to be congruent. All right. Last thing. So it's like, hey, I've got 4 is in the proof now. 1 is in the proof now. How am I going to finish this? What? Finish it? Exactly. Yeah, you're right. Let's finish this. Let's be done with this. If we're all in congruence, how am I going to connect? So I've introduced, let's connect. What do we know? 1 is congruent to 3, just fact, stated, backed up by CA postulate. 3 is congruent to 4, again, fact, justified by the AEA theorem. Where's my connector? 3 connects both of these statements. So what do we do with that? We say, hey, 3 and 3 are connected. That's kind of the link. And that, all right, sweet. 1 is congruent to 4 by the transitive, right? That's what that's called when we create that big chain like that. The transitive property of congruence. Uh-oh, our old connector friend. Okay, that's kind of the essence of the proofs. It's like work your way from this one to this one. There could be multiple steps. That maybe there wasn't maybe there's another angle here or whatever. Like we'd have to work our way over there. But don't let the fact that it's a 2-column proof be like, oh my gosh, I can't do it. Right? I think most people are going to kind of follow like, yeah, these were, I like those. Those are algebra. Those are easy. I would argue that this is less work because there's no algebra. There's no X. There's no find Y. It's just work your way from one angle to another. Okay. So that's the notes. That's lesson 3.2. Hopefully you could see, if you're still not super clear on those names of those angle pairs, go back, rewatch, add notes from 3.1, because just knowing the names of the pairs, like I flew through that proof because I know that 3 and 4 are called alternate exterior angles. I know 1 and 3 are called corresponding angles. I know 2 and 3 are alternate interior angles. So go back and make sure you get that 3.1 stuff nailed down, because that's going to really help you with 3.2. Okay, so we're officially done. That's the lesson. We can call it there. It's a wrap. So I'll look forward to seeing you in future lessons.